Hello and welcome to the next edition of the Isaac Newton Institute podcast. My name's Dan Aspel and I am the Communications Manager here at the Institute. Today I'm sitting down with Xian Chen.
Yes, I'm Xian Chen. I'm from Hong Kong University of Science and Technology. My home department is Mechanical and Aerospace Engineering.
And you're here as part of the Mathematical Design of New Materials program, of which you are a co-organiser.
Yes.
We're right in the middle of it. In fact, we're in a break at the moment in between some workshop talks, and you're very excited to attend them all, so we've grabbed this opportunity to chat to one another. So, from my point of view as a member of staff here, not a mathematician, the program seems to be a very applied one, to have lots of practical applications. Is that the case?
Yes, that's the case. Actually, that's our goal, to propose to have a program here so that we can have mathematicians here. Also, we can have engineers here. The whole program actually is more mathematics oriented. We look at what kind of engineering problems can be understood and be solved, use mathematicians' minds. And also we have two very applied events, one-day event, Newton Gateway event. We also have mixed talks, half from academics, half from the people from industries. People can really chat what kind of challenges in engineering that is closely related to mathematics. Yeah.
So it sounds like a lot of exciting interactions going on,
Exactly.
as you say. Yeah,
Yes.
I mean, and that is typical for a lot of I&I programs, but perhaps even more so here, I suspect. And how does your particular mathematical specialty relate to, for example, what's going on in this week's workshop?
To be honest, I cannot even call myself mathematicians. My supervisor, also a member of scientific committee of this program, he is actually a mathematician. I'm more solid mechanics, so we can't really draw a clear boundary between mechanics and mathematics. So, but we use mathematics a lot. We use calculus variation. We solve partial differential equation. We also look at the existence and uniqueness of the solution to the minimum of some energy minimization problems. So I'm not a mathematician, but I use math to predict and to understand the material behaviors and material properties. That's what I'm doing.
Yeah, so that sounds very fruitful, that kind of interaction between those two groups. And are you finding it personally sort of challenging and enlivening that experience?
Yes.
Yeah, great. And tell me, the work which has been going on in the program so far, what kind of outcomes can you see for the program already?
There are various outcomes in various formats. The first one is that we think there are so many interesting problems arise during the program. And also we have interesting interaction between people from different fields. And in the end, all four of us as organizers, we are going to write a review article to summarize what are the scientific outcomes after this program and what are the further challenges using mathematics to study and understand problems in engineering. That's one of a formal outcomes. And also, of course, there are a lot of collaboration, unexpected and exciting collaboration between people from different fields, from different countries. Because we have people from from Europe, people from Asia, and we all from different institutes. Coincidentally, we work on similar problems. And this is where we come together. We exchange our ideas by giving seminars to each other. And then we sparkle in some ideas, and then we proceed to do some collaboration in future. That's another very, very exciting outcome thanks to this program.
Okay. Absolutely. And if I can ask a very basic question, there's a reference in the title of the program to new materials. Can you give me any examples of what that might refer to? What kind of new materials are we talking about in this sphere?
Sure. So new materials means material have exceptional properties. So if we are looking for materials with exceptional properties, what people usually do, people just do like blending and do a series of experiments, time consuming, maybe takes decades to optimize the material properties. Actually, the initial discovery of some new properties of material is not hard, but to optimize it take decades. That comes to the first part of our program, mathematical design. So by mathematics, people can understand the intrinsic thing of material science and use equations of mathematics to predict the optimum optimum property of the material and how to guide the material discovery, so that hopefully in future we can greatly shorten the development cycle of new material and design new materials based on theory. So that's basically how I interpret this program.
Sure. So as with so many things that happen at the Newton Institute, it's very much the foundation of the science of the future. I think it's quite fair to say.
Exactly.
So you can't point to a concrete product, perhaps, which might come out of a program. It's more saying, well, in 20 years' time, everything will be a lot more efficient because of what we've discovered.
Yes, exactly. Yeah.
Yes, that's very exciting. And the workshop, which is happening this week, we're used to hosting busy workshops, but it's been exceptionally busy this week. And particularly, there was a speaker this morning where we had about 30 unregistered participants joining us from perhaps other parts of the maths faculty, which is very inspiring to see. Do you think there's any particular aspect of this workshop or this program which is drawing in people from other parts of the university?
Oh, absolutely. We have like weekly seminars. Usually we have like 3 seminars each, takes 40 minutes. And we invite many faculties from departments, from various departments in University of Cambridge. We invited this faculty, Chris Pickard. He's from Material Science Department, and he comes over to give us a talk on first principle calculation and material discovery use randomization prediction methods and some machine learning methods. That absolutely fits our mathematical design of new materials. And afterwards we have like refreshment and wine reception, and he can really get in touch with other participants and discuss interesting questions.
Yes, and that's where the real connections come, isn't it, in that social situation. And as we've seen in the past, can lead to collaborations which can change careers and advance the science.
And it also attracts many students from engineering departments to participate the workshops as well as the spring schools. We invite 4 very senior lecturer give sequence of lectures in depth in specific fields, and there are many, not just the participants, but many local students from University of Cambridge come over and participate.
And if I can round off our quick conversation, as I know you need to get back to the next talk, how are you yourself finding Cambridge and the experience of being here?
Besides the cold weather, everything else...
And it's exceptionally warm at the moment, actually.
It's just to get warm, but approach to the end of the program, unfortunately. So like January, February, March is like extremely cold. Since I'm from Hong Kong, which is pretty warm throughout the year, I'm not so used to this kind of weather in May. Other than that, everything else is quite nice. I'm here for a very long time. I mean, not that long, but a couple of months. So I bring my family together with me, and I have a 2-year-old daughter. I find a pretty nice nursery, very close, just 2 minutes away from the institute.
Excellent.
So everything here is very nice.
I'm really glad that's worked out well for you, because it's something that is very important to the administrative staff here, that anyone with a family can access what goes on here just as easily as someone that doesn't. So that's
because 3 months one can count it as a long stay or short stay, but it's very hard to balance the family and the career thing. So Newton Institute is a very nice place. Location is very nice, and all the support from the staff. Our program manager can really deal with everything efficiently. We just send a couple of emails and she just magically make it happen.
Oh, well, I hope she listens to this. I'll pass that on. Fabulous. Well, Sherry, it's been a pleasure talking to you. As I say, I'll let you get back to the remainder of this workshop now. But best of luck with the rest of the programme. And
Thank you.
And thank you very much for your time.
Thank you.
Okay.
Yeah, my pleasure.